Students, this is last video of the elasticity chapter, that is couple for twist in cylinder. So couple means pair, or here couple means basically relates to the torque. It means we are going to rotate something, and that something nothing but this body we are going to rotate, and we will find what is the value of twist. Okay, and so most important part of this thing is to understand this diagram. Student, everything is in this diagram. If you understand this diagram, then 75% part of this derivation is done. So here we have to consider a cylindrical rod. So this is what basically cylindrical rod, and its length is small l. Here is this its length. So and this it has radius r. This is the radius r of the cylinder. So what we have to do here, consider a cylindrical rod of length l and radius r fixed at upper end. So this rod is fixed at this end. Upper end is fixed. It means we are not going to uh, rotate from this cylinder from this part, because it is assumed that it is fixed. When a force F is applied at the free lower end, so this is the free lower end, force is applied, the rod get twisted. So basically we have to apply force, basically we have to rotate it, we have to apply couple of forces. So the line CD attains new position CE. So initially it was, let me clear it, then you will understand easily. So initially it was like this, see this line CD, but when you will rotate it, so this point D will move to the point E. It comes at point E and it will make angle phi vertically, and another angle theta. Here is the theta, you can see in the diagram. I hope you are getting my point, this theta. So therefore the rod is assumed to be made up of large number of thin. Now we have to do derivation, so we can assume that this rod is made up of large number of thin coaxial cells. This is the concept. Basically we have to assume that this rod is made up of many coaxial cells, thin coaxial cells. So from that many coaxial cells, we have to consider one elementary cell of radius x. So this is the radius x. We have to consider this rod. Let me clear it. We have to consider this rod. Actual rod is this. It is having radius x, but we are considering a small thin coaxial rod which is having radius x, this part, and thickness dx. It has thickness dx. Here is the dx. So now, so let theta be the angle at free end, and phi with the angle of shear, because we are rotating it and our upper end is fixed, so there must be shear modulus. So we can write dE in two terms, L theta and x theta. Students, this is very basic formula, arc radius formula. You can say, suppose there is a line, suppose this is the line, this line, and you will rotate this line up to here, like this. You will rotate this line, so this, it will trace some arc. So what is the value of arc? That s, here is the arc is s, and it has radius r, and it made angle theta. So I can write value of that arc s is equal to r theta. So by using this formula we can write L phi is equal to x theta. Here is L phi. See, this is the L length. Basically this line CD is equal to small l, because it is the length. So L, and this is phi, and this is theta. So this CD, in terms of this CD, we can write here this DE. Basically DE we can write L phi is equal to x theta. Why we are equating? Because value of phi must be equal to value of theta, because both are related to each other and same force is applying. So therefore we can write phi is equal to x theta upon L. If you understand till this part, then now everything is very easy for you. So by using formula tangential stress, it means force stress is nothing but force upon area, but it is tangential. So basically we have to use this formula, force upon base area of the cell. So what is the base area of the cell? 2 pi x dx. This is F upon 2 pi x dx. This we have to remember. Now the modulus of, what is the modulus of rigidity? In this case, tangential stress upon shear strain. So tangential stress is what? Force upon base area, and this we have already derived, F upon 2 pi x dx. So F upon 2 pi x dx. And students, what is shear strain? Shear strain is simplified because we have already did a video lecture on this shear strain, why it is value of phi. You can see that video, you will easily understand why we are writing here phi. So going for next step, so I can write eta is equal to F upon 2 pi x dx and divided by phi here. So what is the value of phi? Phi is the x theta upon L. So it is divided by, so we can write mathematically L upon x theta, just reciprocal. So it will be FL upon 2 pi, and here is the 1x and here is the 1x. Here is the 1x and here is the 1x. It become x square and theta into dx. So we can write amount of force what we have applied on the body to rotate. So F is equal to 2 pi x theta x square dx L. Student, don't get confused, this is x, not eta. Okay, because eta is very similar to x. So it is x is the basically radius of the coaxial cylinder which we have considered. So we got the value of force here. Now the moment of force about the axis of rotation AB. So this is the our axis of rotation. This is because we have rotated like this in this direction, So this is our axis. Basically, axis is that part where, in case of rotation, where the velocity of the every particle is fixed, or you can say doesn't change. When you will rotate, so this part is going to fix, and so this part will rotate. So this is the axis, definition of axis basically in case of rotation. And student, moment of force. Moment is a word, basically whenever it comes in physics, it is always related to the distance. When we say moment of force, it means force multiplied by distance. When you will say moment of momentum, it means momentum is multiplied by the perpendicular distance, you can say, or distance. So what is moment of force? Basically this moment of force is nothing but torque, or you can say couple of force. So this moment of force is nothing but force into perpendicular distance, because moment, I already said, moment is related to the distance in physics. So F into x, perpendicular distance is x in this case, which is the radius. So I can write 2 pi x theta upon L into x cube. So this is the moment of force, because we have already calculated the value of force, and 2 pi x theta x square, and here 2 pi x theta, here one more x because it is multiplied by distance, so x cube dx upon L. So the twisting couple or torque is, so we can write this is as torque is tau is equal to 2 pi x theta upon L into integration of 0 to r x cube dx. Why we are integrating? Because we want to find out the total effect produced by the force, and the limit taken is 0 to r. And why this term taken out? Because 2 is the number, pi is the 3.4, that is fixed value, x is the radius of the considered coaxial cylinder, theta is the fixed, and L is the length, which is also fixed. So basically these quantities are constant, and we do not integrate constant quantity. So since it is multiplied, so it will come out of the integration, and we will integrate this term. So why this term? Because when we will rotate the cylinder, because cylinder is elastic, so its radius will decrease because of rotation. So it means its radius is changing. So we can integrate changing quantity. So you will get 2 pi x theta upon L here, and simple integration of x is nothing but x raised to 4 by 4. That is the formula of x raised to n. Is integration of x raised to n. Integration of x raised to n is equal to x raised to n is equal to x raised to n plus 1 divided by n plus 1. Sorry, basic formula, first formula of the integration. You already studied in 12th standard. So you will get x raised to 4 by 4 and limit 0 to r by putting the proper value, by putting the limit of integration. You will get 2 pi x theta L upon r raised to 4 upon 4, because in case at place of x we have to put r here. So r raised to 4 by 4. So this 2 will cancel 4 and you will get this equation. So I can write t is equal to c theta. Why c theta? Because again students, here pi is a constant, x is the constant, r is the radius which is fixed, 2 is a number which is also constant, and L is the length of cylinder which is not going to change. So this whole term is constant. So we can write another term, that is c and into theta, and this c pi eta x r raised to 4 divided by 12 is known as torsional constant. So term t by theta is equal to c is equal to couple required per unit twist. It's called torsional rigidity. So this is the derivation. So hope you got each and every point here. If you have any doubt or inquiry, you can ask me, and you can share with your friends, and clear all your doubts. And with this is the end of all the video lecture related to the our chapter elasticity. Thank you so much for